Good afternoon, good morning, good evening. Hello, guys. Today we are going to talk about, I forgot. Hi, Cameron. Today we're going to talk about the structure of the atom. We're going to talk about nucleoid symbols. We're going to talk about where all the subatomic particles are in an atom. Remember, there are 3 subatomic particles. By subatomic particles, I mean sub meaning within, and atoms, atomic, within the atom. So there's 3 subatomic particles. We have our protons, neutrons, and electrons. So there's those 3 that we're going to talk about, protons, neutrons, and electrons. As we're going through this, guys, you might want to pick up this sheet of paper from the front desk and jot these notes down, okay? So in terms of a definition, first thing, we're going to talk about protons. Where are my protons located? Protons are located in the nucleus, and they are positively charged. My neutrons are, again, in the nucleus, and they are neutrally charged, meaning they have no charge whatsoever. Okay? And then we have my electrons. They are, it's trying to find me. They're actually in the electron cloud. They're outside the nucleus. We call that the electron cloud. And those guys are negatively charged. Okay? So, when we talk about a nucleide symbol, there's 2 ways that we can write a nucleide symbol. We can write it with the symbol. So I'm going to work on potassium. So I write the symbol. And then the number in the upper left-hand corner is the mass number. And so for potassium, I'm going to say it's 40. And then the bottom number is the atomic number, 19. So nucleide symbol is either written that way, or it's written with the symbol as well, hyphen, and then mass number. Okay? It's written either way. So let's come down here and talk about the different parts. The atomic number. The atomic number is equal to the number of protons in an atom. Okay, so I said that this was my atomic number. That is telling me the number of protons in potassium. This whole number, the number of protons, is always on the periodic table. Okay, we can always find the atomic number on the periodic table. And it is the whole number. If you look at your green sheet that I gave you, notice how in the upper here there is a key of where it is. It's the black number. Bolded black number is the atomic number. It's always a whole number because you can't have a half of a proton, a quarter of a proton. It's either 1 or 2 or 3 or 4. It's a whole number. This is also equal to the number of electrons. E minus is my symbol for electrons. However, this is only if the atom is neutral. Okay? So if the atom is neutral, the number of protons and electrons are equal. This number is also unique for an element. It helps us identify it. Because if you look on your periodic table, there is not one element or 2 elements on the periodic table that have the same atomic number. The atomic number helps us identify the element. Okay? So, I'm going to go back down, scroll down my sheet here, and now let's talk about atomic mass, because this is where it gets tricky, okay? And I'm going to flat out tell you right now, and for probably about 8 kajillion times from here on out, the atomic mass number of an element is not found on the periodic table. The mass number is just for one particular atom. Okay? So the mass number, it represents the particles in the nucleus. Okay? Which means the mass number represents protons plus neutrons. Okay? So I'm going to skip down here real quick. It's equal to the number of protons plus neutrons, because that is what is in the nucleus of our atom, protons and neutrons. What is shown on the periodic table is the average atomic mass. Okay? The mass number is just for one atom. The average atomic mass on your periodic table is for multiple atoms. So if I had 5 atoms in this room, 5 hydrogen atoms, they all may have different mass numbers. So I could say this hydrogen has a mass number of 2. This one has a mass number of 1. This one has a mass of 1. This has a mass of 2. But if I add them all up and divide by however many I have, that would be the average atomic mass. The average atomic mass is what we get on the periodic table, not the mass number, because mass number is telling us for just one particular atom. How many protons, how many neutrons. So the mass number, again, also must be a whole number. This number can be changed based on which element is represented. However, different elements can't have the same mass number, okay, because of the size of the nucleus. Okay. So let's quickly talk about ions. Okay. Ions are an atom that is not neutral. It is charged. And by charged, it can be either positive or negative, meaning it has more protons than electrons, or more electrons than protons. Notice how I'm saying nothing about neutrons. Why? Because neutrons are neutral. Okay? I can have 3,632 neutrons in it, and it would not change the charge of that particular atom. Okay? The charge of the atom is protons minus electrons. Honestly, or vice versa, it really doesn't matter. Okay? So then if we have multiple elements, multiples of the same element. So if I fill this room with all potassium atoms, not all potassium atoms will have the same mass number. They're going to be slightly different. Okay? This is what we refer to as isotopes. Isotopes in nature may differ among the types of atoms. How? It's because they have different, I'm just going to come down here, they have different mass numbers. If they have different mass numbers, remember mass numbers, protons plus neutrons. If I'm talking about an isotope, it has to be the same element, which means the number of protons doesn't change. But if their mass numbers are changing, that means that they also have different neutrons, different number of neutrons. Okay, so let's take a look at a few. I'm just going to erase all of this. So let's take a look. If I take a look at potassium 40 and potassium 39, and I ask you the number of protons, the number of electrons, and the number of neutrons. So potassium. How do I find the number of protons for potassium? I look on the periodic table. I find potassium, find the atomic number. So potassium's atomic number is 19. So since both of these are potassium, there's the same number of protons, which is immediately telling me that these two things are isotopes. They are the same element. Now, number of electrons. Notice how if it was charged, there would be something right up here in that right-hand corner. It's not, which is telling me that there are the same number of electrons. So I have 19. Now on to my neutrons. How do I determine the number of neutrons? I take my mass number and subtract out my electrons, or my protons. So we have, same thing here, 39 minus 19, so this is 20. This would be 21. Okay. If I add another one to this mix, if I ask you, we'll do, I need my periodic table. We'll take a look at oxygen, okay, and I'm looking for number of protons, number of electrons, number of neutrons. Protons, notice how I wrote my nucleoid symbol this way. This bottom number is my atomic number. And remember, my atomic number is equal to the number of protons. So boom, 8. Now, number of electrons. You'll notice something different about this one. Okay, I have this up here. It's telling me it's a -2 charge. Can I take away 2 protons? No. If I change the number of protons, I completely change the element. So I cannot take those away. So I have to add the number of electrons. I need 2 more electrons than my protons. So I have 8 protons, so I need 10 electrons. Number of neutrons, it doesn't change the way we calculate it. Mass number minus protons, so that's 8 neutrons. You should be able to find any combination of protons, neutrons, and electrons from the information I give you. Okay? Have fun, guys.